Okay, so in this video we're going to talk about triangle congruency. All right, so what does it mean for a triangle to be congruent? All right, so what we see here is we have two triangles. Now when we say congruent, right, what we mean is that the triangles they fit together. All right, so if I overlay them exactly on top of one another, we get just what looks like one triangle. All right, so that is kind of the definition of congruence. So now let's kind of dive into the properties. Well, what does it mean in terms of the parts of the triangle, right? And by parts, I mean the sides and the angles, right? As we see here, right, the triangle has three sides and it has three angles, right? And a reminder, the sum of all the angles in a triangle is 180 degrees. Okay, so let me switch over here and take some notes here. So when we have two triangles and we say they're congruent, right? So here, let's say, draw a triangle here. And let's say I'll label this. So a couple things we'll go over here is, first of all, some naming conventions here. F. Okay, so the triangle here where the vertices, which I've labeled A, B, C, right, we denote by triangle. We use that note A, B, C. Okay, now if I want to denote the two triangles, let's say, for example, that I knew or I was given the information that these two triangles were congruent, then I would say, all right, triangle ABC is congruent. And I use this symbol, which is like an equal line with like a tilde on top of it. All right, is congruent to triangle DEF. Okay, now one thing to note here is that the order of these letters is going to matter because it does tell me the relationship of congruency, right? It does tell me what we call corresponding parts, right? So what I mean by that, if these two triangles are congruent, right, then based on this statement here, right, that means that their corresponding sides are equal and the corresponding angles are equal in measure. Right. So in other words, here, the way I can take the correspondence here is, let's look at the angles first. Angle A is corresponding to angle D, right? So this is angle A, and then this is angle D. All right, so we can make a statement like the measure of angle A is congruent to angle D. Okay. Now, when dealing with numbers and values, we use an equal sign. When dealing with geometric type objects, we use this congruency symbol. All right, and then in a similar note, we could see angle B is congruent to angle E, right? So we use like the double one here. Okay, so angle B is congruent to angle E. And then in the same way, the last angle here, angle C, we have and angle F, these are both congruent, right? So angle C congruent to angle F. All right. Now, not only are the angles congruent, but so are the corresponding sides, right? So again, if you see this here, the way you kind of read this, you can read this as AB congruent to DE. All right. So the sign, the sides. You can say now AB congruent to DE, which means they have the same measure, right? They have the same length. Right? And then you can take the same approach here, right? Reading the triangle here, BC, right? So usually these are denoted by tick marks, right? All right, BC is congruent to EF. All right, so BC congruent to EF. And then lastly, our last corresponding side here, AC is congruent to DF. All right, so AC congruent to DF. And now we've established the congruency relationships here. Now, it is important to realize when you do write those triangle congruencies, the order of the letters does matter because it does tell you which what are the corresponding angles and sides. Now, the individual parts, at least for the sides, right, like AB is equivalent to BA, since we're just focusing on that segment there, then that order really is not going to matter, right? But it is very important when dealing with the triangle, with the triangle congruency. Okay. All right. Now, one last thing here in terms of just kind of naming angles. So if you look at the triangle, it's clear what angle A is. In some cases, it won't be clear. Like, let's say here, let me just to kind of have another naming convention here. Sometimes, let's say we have a triangle that looks like this, and we have A, B, C, D, E. Excuse me, I should say two triangles that are kind of constructed in this manner here. All right. Now it's clear what angle A is. It's clear what angle B is. Right. What is not clear is which one. If I say angle C, what am I referring to? Right. So we have to be very explicit to determine: am I talking about the angle here, this angle here? Right, or am I talking about these angles over here? All right, so it's not clear which angles that I am referring to when I say C. So we use the naming convention where the letter C will be our kind of vertex here. And we're going to use the letters A and B to kind of help us name the angle here. So if I say the measure of angle A, C, B, right, then I'm referring to this particular angle here, right? That value C will always be in the middle. It's the vertex of the angle. So it's here we have A, C, B, right? You just kind of trace it, right? Starting at A, going to C, and then B, right? That helps distinguish, for example, like if we were to say DCE, right? So let's switch colors here. So if I were to say the angle DCE, right, that would reference this angle right here. Okay, so just a naming convention here when we have something that isn't as clear, right? If we have two separate figures, sometimes it's easy to refer to one letter. Not all the time it wouldn't be clear. Like if you said angle C, I would not know what that measure would be. Okay, thank you.